Welcome everyone. Today I'm presenting the dog recognition system in Python, a project designed to help shelters and organizations to manage their dog databases using machine learning and computer vision. Our focus is on Penkta Koja, a dog shelter that takes in around 800 dogs a year. This system is about automating the identification process to make it more efficient and accurate. The purpose of this system is simple but critical: to help identify lost or homeless dogs. Many shelters like Penkta Koja have large volumes of dog photos, but identifying a particular dog manually can be extremely time consuming and error prone. We aim to automate this process by using a machine learning based system that can recognize a dog from photo and match it to the shelter's database. This reduces human effort and improves the accuracy of identification. On this slide, we present a dog recognition algorithm. We start with a photo of the dog we want to identify. On preprocessing step, we resize and normalize this image. For future extraction, we use Python pre-trained neural network model VGG16. The same procedure was done also with our initial dog database. So we have all dogs extracted futures and stored them as vectors in NumPy array. The next step let us compare input dog image with those in database and select most closely records using nearest neighbors algorithm. The last step of algorithm outputs recognized dog identity. On next slides, we will describe the steps in more details. One of the most important steps in building this system is organizing the photos of the dogs. We propose setting up a structured database where each dog has its own folder. The root folder will contain subfolders, one for each dog, with multiple images of that particular dog. For instance, you'll have dog one's folder containing images from different angles or over time. This organization makes it easier for the system to retrieve and compare images efficiently. Preprocessing step. In this step, we prepare the dog images for analysis by a machine learning model. Two key operations happen here: resizing and normalizing. First, we resize all images to a fixed dimension like 224 uh, and 224 pixels, which is a requirement for many deep learning models like VGG16. Second, we normalize the pixel values so that all images are within the same data range. This is crucial for improving the model's performance because consistent input data helps the model learn better. We use the Pillow library in the Python to handle this preprocessing task. Once the images are preprocessed, the next step is feature extraction. Here we use a pre-trained convolutional neural network to extract key features from the images. BGG16 has already been trained on millions of images, so it knows how to detect patterns like edges, shapes, and textures. These patterns are then transformed into what we call feature vectors, basically a set of numbers that represent the most important characteristics of the dog in the image. These vectors will be used later for comparison. When we have future vectors, we need a way to store them effectively. We use NumPy arrays to store each dog's future vector along with a label that tells us which dog it is. For example, dog 1 might have a future vector like 0.12, 0.34, and so on. And this vector is stored with a label like Labrador Retriever. This reduces the complexity of raw image data, making it easier for the system to manage and compare dog. Now comes the exciting part, comparison and matching. We use an algorithm called K-nearest neighbors to compare a new dog's future vector with all the stored vectors in the database. Uh, KNN measures the similarity between the new dog's futures and those of known dogs. It doesn't just look for the closest match. Instead, it considers the closest neighbors to make a decision. For instance, if k equals 3, the system will check 3 closest matches, and the majority vote will decide which dog the new image most closely resembles. After comparing the new dog's image, the system will provide an output in one of two ways. If it finds a match, it will return the label of the dog, like recognized dog, dog number 3. If the system determines that no known dog is close enough to the new image based on a set distance threshold, it will report the dog as unknown. This prevents the system from incorrectly identifying a dog that isn't in the database. Finally, let's talk about the strengths and potential improvements. One of the key strengths of this system is its accuracy. The use of VGG16 for future extraction combined with KNN ensures a robust cognition process. It's also scalable as more images are added to the database, and it's relatively simple to implement. However, there is always room for improvement. For instance, fine-tuning the recognition threshold can help reduce errors. We could also implement data augmentation to improve the model's performance on more diverse images, and eventually we can work towards real-time recognition with large database. On this slide, we can see the program code of dog recognition system. Next, we will present how this program works for unknown dog identification. To demonstrate our program, we use Spider for Python. Spider is a free open source scientific environment for Python program, to run Python program, to combine advanced analysis, debugging, editing, and profiling other possibilities. Here you see the program we will run. To run, it is enough to press the button in the Spider run file. After that, we need to choose our initial database. So we browse with the folder with our dog uh, pictures, photos. So we choose it. Then we choose the dog which we want to identify. So let it be this one. And it's enough just press the button recognize dog. You see the program is calculating dogs database futures, also calculates the feature of the dog we want to identify, and after that the result will be displayed on the same screen. We need to wait several minutes. I think it will finish soon. So, as you see here, the dog is recognized. Here is the dog name, and here is the